How's it going, everybody? Welcome to the video here where we're going to go over the entire Part 1 Regents exam from June 2023 for Algebra 2. For this video, I'm going to show you how to do all the problems using whatever methods we learned in class and also using the Desmos calculator. The hope here is that you've actually tried some of this on your own and you're just kind of using this to check. But if you are using this to teach yourself, that's fine too. Just make sure that you are reviewing all the skills here. This was a really good Regents exam because it kind of goes over all the topics. There was really very few missing things that pop up on other exams. So this is a really good one to go over. So let's jump into it. For question number 1, they give us a table of values comparing year and population in a town called Austin, Texas, between 1850 and 2010. They asked us over which period of time was the average rate of change in the population the greatest. So as soon as we see the words average rate of change, we're thinking it's the function value minus the function value divided by the interval values. Notice I'm putting B first, A second. So in each one of these, A is first, B is second. So we have all of these A and B values that we can use. Now, for this question, since it's a table, we don't actually have a function to plug into. We just have to use the numbers. So if I wanted to find the average rate of change for choice 1, I'd have to look at the year 1850 and compare it to the year 1910. So for choice 1, my average rate of change would be 29,860 minus 629. And then if I divide by the years, which represent my interval, from 1910 back to 1850. Now, if you plug that into your calculator, you get about 487. These are all going to be very different. They're not going to be so close where the decimals matter too much, but we'll see as we go. So for choice 2, I want to look at the interval from 1990 to 2010. So I'm only looking at these 2 points. So we have 790,390 minus 494,290 divided by 2010. That's not 2010. 2010 minus 1990. Now, if I type choice 2 into my calculator, I get 14,805. So far, choice 2 is our winner. But let's see. So if we look at choice 3, we're going to be comparing 1950 to 1970. That's definitely not going to be bigger than choice 2, but we'll do the math just to practice. 251,808 minus 132,459 divided by 1970 minus 1950. You can see the biggest jump in population happened here, but we have to take account the years as well. That's what average rate of change takes an account for. And this is about 5,968-ish, 67.5. And for choice 4, 1890 compared to 1970. So the biggest change in years. So let's see. So if we do 251,808 minus 14,575 divided by 1970 minus 1890, we get the value 2965. So the one with the biggest change was choice 2. Number 2, which expression is not equivalent? They love using the word not. Look for it in multiple choice for sure. So they want to know which of these would not multiply back out or do any kind of algebra to give you back this expression. There's a couple ways you could do this. I'm going to use algebra skills to do this, but since it's an equivalent expression, you could go right onto Desmos and plug that expression in and then plug all your choices in to see which one gives you the same graph. That's a good test-taking skill. If you're not sure what to do, graph it. But if you look at choice 1, this would multiply out. 6 squared would make 36. X to the third raised to another power of 2. Power to power gets multiplied, so we're practicing our exponent rules here. 5 squared is 25. Y squared to the second power becomes y to the fourth power, so that's the same. To determine if choice 2 is the same or not, I'm actually going to use factoring. This can be factored using difference of two squares. So I can get 6x cubed, because that's what would multiply to itself to make 36x to the sixth. We get a plus and a minus. And then what multiplies to itself to make 25y to the fourth would be 5y squared. So that works. I know I put the plus first, but it's the same thing backwards. So you could then clearly see that choice 2 and 3 almost look the same, but they have different exponents. The exponents are wrong. That's my answer. That's not equivalent. The last one just had you see that 3 times 2 can be multiplied to make 6x cubed. And 6x cubed. So then these two would be equivalent. So 3 is the only choice. That does not make sense. Number 3 gives us a function s of x. It's a quartic function, which means it can have a possibility of having a maximum of 4 x-intercepts or 4 solutions. Some of these solutions might be real. Some of them might be not real. This is something that we could try and factor. It has 6 terms. We could do a whole grouping method of factoring. But since it's multiple choice, why would we want to do that? We can use our calculator. So if we go to our calculator here and we plug in s of x. So if I plug in s of x equals x to the fourth minus 9x to the second plus 3x to the third minus 27x minus 10x squared plus 90, I can see that it clearly intersects the x-axis at the points -5, -3, 2, and 3. So we can choose our correct solution, which would be number 4. If I was to do this by grouping, I would make it into 3 separate parts because the exponents change. So notice how it goes 4 to 2 and it goes back up to 3. So that's an indicator for me that if I was to do grouping, that's what I would do. And you could go through and factor the whole thing. That's not a bad thing to do here. But for multiple choice, we want to use the calculator if we can. All right, number 4, it gives us an angle in standard position. And it determines the terminal side goes through the point -2, -3, and I want us to know the tan of that angle that's created. So right away, we know that this is a quadrant 3 angle because that point is in quadrant 3. So we're going to draw quadrant 3. We're going to draw a ray representing the terminal side of the angle that rotates all the way around to here. This is theta. We then can draw our right triangle. Remember, the right triangle always makes a perpendicular line with the x-axis. And then we have our little reference angle here. The tangent value of the reference angle will be also the tangent value of theta, determining also what quadrant we're in, whether it's positive or negative. So right away, because it's multiple choice, I know in quadrant 3, tangent is positive because all are positive in quadrant 1, sine is positive in quadrant 2, tangent's positive in quadrant 3, and cosine's positive in quadrant 4. So since they want the tangent value, I know it's not these two choices. Now, if we're looking at this coordinate, I would move to the left 2 and down 3 to get to this point. So this side of the triangle would be 2, and this side of the triangle would be 3. Because I would move to the left 2, so that means this would be 2 boxes. This would be 3 boxes down if I had it on graph paper. Now, because I want tangent, we know that the tangent value of any angle is equal to the opposite side over the adjacent side. So if we label this triangle up, this is opposite, adjacent, and the hypotenuse, which we don't know. We don't care about for this problem. And since we want tangent, we want to pick the opposite over the adjacent side. So that would be choice 2. Number 5 gives us the function T of M, which represents the degrees Fahrenheit in a town or somewhere, and it's the average of that town temperature. Now, temperature is going to fluctuate. It's going to oscillate between the maximum and minimum numbers, and there's a lot of stuff going in here. We have a negative leading term. We have a cosine function, so we know that it's going to be an upside-down cosine graph like this. We have a frequency of pi over 6, meaning we can find the period, and we have a midline. Now, depending on what they ask, you might need to use one of those parameters of this sinusoidal function. You might need to graph the whole thing. But for this question, it just asks us for range. So they would just want to know the minimum and the maximum. That's all they want for the range. Well, to determine that, I just need to know the midline, what's halfway through the graph, and the amplitude, how far does it oscillate up and down. So if I take 56, the middle, and I subtract 23, I'm going to get the bottom of the graph, the minimum value, which would be 33. If I take the middle of the graph, the midline, and I add the amplitude 23, that would be where the top of this graph is, which would be 79. So my range is from 33 to 79. Say you forgot that. You could totally graph this, make sure that you're in radians on Desmos, and you should be able to see that the graph goes down to a minimum value of 33 and then up to a maximum value of 79. Number 6, which expression is equivalent to a times the fifth root of a to the fourth? So for this, we need to know the rule of exponent over root. So we can take a, leave it as is, this a on the outside. And this radical I can change to a to the 4/5. The exponent's 4, the root or the index is 5. Now from here, we have to use our properties of exponents. So when we multiply variables, we're going to add their exponents. So I know I'm going to get a to the 1 plus 4/5. Well, for those of you that aren't great with fractions, go to Desmos and just type in 1 plus 4/5. It's going to give you a decimal, but then you'll notice the little fraction button over there on the side. We see that it comes out to be 9/5. So this becomes a to the 9/5. There you go. You just got another question right on the Regents exam, if I circled the right one. Choice 2. Number 7 is one question where you can't really use the calculator too much. You really need to know some rules here. So if we distribute the 3i in, we get 3ai squared, I times I is I squared, minus 18i to the third. Well, the powers of I, remember, I is equal to itself. I squared is equal to -1. I to the third is equal to -I. And I to the fourth is equal to +1. If you remember that the even exponents are going to be either 1 or -1, the odd exponents are I or -I, it kind of helps you there. And I remember when you're trying to find bigger powers of I, you have to figure out how many times 4 goes into that. And then your remainder is one of those 4 options. Luckily for us, it's just I squared and I to the third, so we can use what we already memorized. This has to be memorized. So since I squared is -1, we have 3a times -1 minus 18 times -I. Then we just have to deal with some sign issues, right? So we have a negative times a positive. That's going to be -3i. We have a negative times a negative, which gives us positive 18i. So we have -3a plus 18i, choice 3. The next one wants us to determine which equation can represent the logarithmic graph that's shown here. So there's some variables mixed in here, so we're getting some rules of functions and knowing how they move, change. One nice thing is they all do have the same base. They're all base 10 logarithms. So it's really just determining what's moving this function. How are we moving this function? So if you know what the original function looks like, the original function is going to have an x-intercept at 1, 0. It's going to have a vertical asymptote line at the y-axis, and it's going to come up and look something like this. We're trying to determine, how did we move this point to here? Well, I moved it to the left 2, up 1. Or I moved it to the left by a certain amount and up by a certain amount. In this case, it's A and C. So if you notice, I'm moving everything to the left A. So the vertical asymptote line now becomes -A. So I moved it that many boxes, 2 boxes or A amount of boxes to the left. And the C value moved everything up by the 1 box or the C amount of boxes. Well, when we're dealing with functions, to move a function left or right, it's going to add or subtract something in the function. So that means A is going to be in the logarithm, which they all are. If we're moving something up and down, it's going to be outside of the function. So that means C is going to be outside the function. That's where the C's are. So right away, I know it's not choices 3 or 4 because these both would move it down C. Now to move something to the left, any function to the left, we're going to add how many units we move to the left. Because remember, whatever's in the expression or in the function is going to act opposite of what you think. So we'd have choice 2. So for number 9, what we have to do here is understand what end behavior is. So end behavior is what's happening at the ends of the function. So we could see that the function is giving us, or the question is giving us one part of the end behavior. This is only half. So this is saying as the x values decrease, the function values, the y values are also decreasing. Meaning this graph is going to be pointing down on the left side of it. I don't know what's happening on the other side. Whatever happens in between, I don't care. But I know that it's going to be pointing down on the left side. So it can't be choice 1 or 2 just by the graphs that they gave me. So now to figure out which one it is with what's left over, I'm going to graph it. So if I go to Desmos, I can graph those two options and just honestly see what they look like. So I have f of x is equal to 5 times 4 to the power of negative x. Well, I see that that's going to be going up on the left-hand side, so that's not my answer. And then we have a possible f of x is equal to negative log base 5. So we got to use the log button here. I got to move this. I don't know what this is. So let's move the log by going to functions. Go down here to where it says log base a. So we could say log base 5 of negative x. And we can see if I move this out of the way, we get a graph that's going down as the function values decrease. That's the only one that does that. So this one looked like this, and this one looks like this. If I look at the graph again, just to make sure I have it right, there we go. So it looks something like this. This is the only one with this end behavior, so that's choice 4. Number 10 wants us to determine which expression is equivalent to the given expression. So there's a couple things you can do here. You can multiply the whole thing out and get an expression and then try and factor it. That's a lot of algebra. But what I notice, what I'm hoping you notice, is that these two expressions in the parentheses are the same. And they're what are making this thing challenging to factor. So I'm going to replace them with a different variable like m. And I'm going to rewrite this without x squared plus 3 in it. So I'm going to say, well, that's going to become m squared minus 2m minus 24. And then I'm going to factor it just like I'd factor any trinomial. I'm going to say what multiplies to the last number and adds to the middle number. And the two numbers that make that work are going to be negative 6 and positive 4. So I can factor that to m minus 6 and m plus 4. Notice that's not a choice because I don't even have m in this problem. So I got to replug m back in. So instead of m, I'm going to put x squared plus 3 minus 6, right? I'm replacing m with x squared plus 3, and x squared plus 3 plus 4. We then can clean up what's inside the parenthesis to get us to x squared minus 3 and x squared plus 7. There's my answer. The next one asks us to solve a system of equations. Any system of equations that's in part 1 is going to be done on the calculator. It makes it so much easier. So if we go to Desmos and we start graphing some stuff here, so we could say x plus y plus z equals 2. It's going to ask you to add a slider, so you could go ahead and do that. And then type in your other two equations in the system. X minus 2y minus z equals negative 4. And x minus 9y plus z equals negative 18. Now our goal for this system is to move the slider until all three lines intersect at the same location. So if I move my slider, you'll see if I move it more positive, that it gets further away from intersecting. If I move it closer to 0 or more negative, eventually they do intersect when 0 is the z-value. So when 0 is the z-value, we get an x value of 0, a y value of 2, and we now from the slider know that the z-value is 0, so we can quickly get this answer and say it's choice 3. Number 12 asks us for the roots of the equation. Solutions, roots, kind of the same thing here. They want us to solve this quadratic. Notice your choices either have I in it or radicals in it, so that means it's not going to be factorable. You're going to have to use the quadratic formula here. So the first thing I'm going to do is move the 13 back to the other side so that I have this equal to 0. Whether I'm factoring or using the quadratic formula, I need to be equal to 0. The quadratic formula is given to you on the reference table, so you could take a look at that. So it's the opposite or negative b, so positive 4, plus or minus b, so negative 4 squared, minus 4 times a. A in this case is 1, there's a 1 there, and c is 13, all divided by 2 times 1. Now, when you're doing this, you need to know what the number is that's underneath this square root. We call it the discriminant. So I can replace that number with what it's equivalent to. So if I type that into my calculator without the radical, just this part underneath, I get negative 36 all over 2. That right away should tell us it's not choice 3, because the radical has a negative underneath it. The square root is negative. That's going to tell me it has I in my answer. Now, to determine which one is the right answer, I'm going to separate into 2 fractions. I'm going to share the 2 to both the 4 and the square root of negative 36. Now, the square root of negative 36 is a perfect square, so the square root of 36 is 6, so the square root of negative 36 is 6i. Notice 4 over 2 becomes 2, and then I can simplify this even further to get just 3i. So your answer is choice 1. Number 13 asks us to do some division. So we can go through and divide this. How do I know it's division? If I look at my choices, it's all a quotient plus or minus some type of a remainder divided by 2x plus 4. So I'm going to make some boxes. I'm dividing by 2x and 4. I'm trying to recreate this. Notice there's a 0x squared. There's a missing term. So I need to make 2x cubed in my first box. The next set of boxes have to add up to no x squareds or 0x squareds. The next 2 boxes have to add up to 2x. And the last box should be negative 7, but we know already it's not going to be because all 4 choices have remainders. So if we start doing the math, we're going to ask ourselves lots of questions. What could I multiply 2x by to make 2x cubed? Well, that would just be x squared. Well, that's x squared. This is 4x squared. But I want these 2 boxes to add up to 0x squareds. So what do I add to 4 to make 0 would be negative 4x squared. Then I have to restart the process again. What do I multiply 2x by to make negative 4x squared? That would be negative 2x, which would make this negative 8x. Well, then these 2 boxes together have to add up to become positive 2. So what could I add to negative 8 to make positive 2 should be positive 10x. So then we'd have a 5 here because 5 times 2 makes back 10, which would give us 20 here. Now to determine the remainder, we're saying to ourselves these 2 things don't add up. So I'm saying 20 plus some remainder that I don't know is equal to negative 7. So if I solve for the remainder by subtracting 20 to both sides, I now know that the remainder is negative 27. Choice 1 is the only one with a remainder of negative 27. Notice the quotient is correct as well, and the remainder is divided by the divisor. Okay, number 14 tells us that we have an exponential regression equation that we're trying to model, and then we want to know how many followers this person has on social media on a certain date. So the first thing we have to do is we have to create a regression model for this. So to do that, we're going to say y1 is approximately your A times your B to your X1. That's what we're going to type into the calculator in Desmos, but we first have to put in this table. So let's go over to Desmos, get rid of all of this junk that's in there, and let's make a table. So to make a table, you're going to hit Add, Table. Notice the two columns are already X1, Y1, so you could just leave them like that, and type in your data. So 2, 11, 16, 20, 27, 35, 47, 50, and 52. And then if you type in your Y values, 3.1, 7.5, and just keep going until you get them all in. Just give me a second there if you want to fast forward to me not typing, that's totally fine. Before you do anything, once you have all of your numbers in, make sure you check because it looks like I missed one. I did. So I missed 49.7. Kind of just a quick check, just make sure that you have all of your data. Remember, you have 3 hours to take this test, so it's okay to double check. You have plenty of time. Okay, so we have all of our numbers. Okay, so we're good. So now all I have to type in line 2 is y1, and then make the little squiggle. A times b to the power of x1. And then remember to click log mode. That gives you the best possible answer. And now we have our function. So it gives us an a value and a b value. So our a value is 1.76796. Our b value is 1.18483. So we can say our y value is approximately 1.767. Our b value is approximately 1.185. 3 decimal places are usually good. Now, remembering that X represents the number of months since January of 2015. So I have to determine approximately how many months it is from January 2015 to June 2018. So from January 15 to January 18 would be 3 years. So that would be 36 months to get to January 1st, 2018. And then we have to go from January to February to March to April to May to June. So we'd have to add 5 more months to this. So we have a total of 41 months. This is your X value that we're going to plug in here. So if I go back to Desmos, I can make my equation and just say 1.76796. We can even round a little bit more since we have the number right in front of us, be as accurate as we can. 1.18483, and raise that to the 41st month. And would have 1850.5. Now you have to remember that this answer is in thousands. So we'd have to take that number that we just got and we'd have to multiply this number by 1,000 to get my real answer. And it's going to be an approximate, right? It's not going to be perfect because it's a model. So we're predicting the number. So we have about, 1,850,000 people. So the closest answer we have is actually choice 3. Number 15 talks about this light bulb, and it gives us an equation, and it says the function can be best approximated by. So if you look, all we're really doing here is we are trying to figure out which of these models that are my choices are equivalent to the one that's given. So there's a couple that still have E in it. So we have to ask ourselves, can I do anything up here to keep E? So essentially, I'm just going to start working the equation. So I sub 0, E. This 3 can be multiplied to this fraction. If I do that, the fraction is going to become negative 3t divided by 0.6. That's not going to give me 18 because the 3 is in the numerator. If I divide 3 and 0.6, it's not going to give me 0.5 of 5, so it's not choice 2. If you're not sure what I mean by that, if you divide 3 and 0.6, essentially simplify that fraction without the variable, it's going to give you a different number altogether. So if you divide 3 divided by 0.6, you do get 5, but notice there's no negative. The negative doesn't just magically disappear, so it can't be choice 2. So now we're on to the other remaining choices. Well, the other remaining choices have just t in the exponent and 0.6 in the exponent. So let's try and make t in the exponent. So to do that, I'm just going to ignore this. I'm just really caring about this part because that's the only thing that's changing. So I'm going to say e to the negative 3 over 0.6 to the t. I can do that with my exponent properties. Well, if I type that into my calculator, so if I do e to the exponent of negative 0.6 divided by, negative 3 divided by 0.6, I get that decimal that is the decimal that's in the base now. So this 0.0067 number is equivalent to this. Number 16 talks about normal CDF. How do I know it's going to be normal CDF? Well, it tells us that it's approximately normal distribution. So we're going to have a bell curve of some sort. It gives us the mean and the standard deviation, and it wants us to know about two different heights. So it wants us to know heights that are less than 60 and greater or greater than 75. So we have to find two z-scores here. So we're going to find the z-score for 60. So I'm going to do 60 minus 68.1 divided by 3.4. That's going to be my lower z-score. And that lower z-score is going to be negative 2.382. So I know that my z-score on the bottom is going to be shaded down. I care about this probability or this percentage. The upper z-score is going to come from the value of 75. Again, we're going to subtract the mean and divide the standard deviation. If I do that, I get the upper z-score of 2.029. So I want to be above that number. And I want to add these two together. So I want to be able to do that on my calculator. So to do normal CDF in your calculator, you're going to go over here to functions, go down to the distribution menu, go normal distribution. Remember, we always use 0, 1 because we like z-scores. And let's do the bottom section first. So we're going to go from negative infinity, so just leave them in blank. And we'll go up to negative 2.382. That's going to be our part on the bottom, so 0.0086. So this is going to be 0.0086. We also want the part on top. So if we go back here and we make the minimum number 2.2029 and the maximum number just leave blank, let's get rid of it completely, you'll see the chance of the top part, 0.00138. 0.0138, sorry. So now if I add those two percentages together, I get my answer. So if I do 0.0138 plus 0.0086, I get about 2.2. as my probability. Oh no, this is 029. That top number was wrong. 0.02122. There we go. That's closer to what we want. All right. So that number was wrong that I had there. My bad. This probability should be 0.0212. There we go. That's better. All right. So now we have our right probability for the top. If we add them together, we get about 2.98%. Now, the other way that we could have done this, which I like better, would have been to make the shaded area in between and then just subtract it from 1. I don't think you would have done it that way, but it's a little bit easier. So if we do 382 as the bottom number, and we do 2. Let's type it in right this time, 029 as the top number, this is the chance of it not being what we want. So if I subtract 1 minus 0.97 0.16, you'll see we have that same probability or that same percentage of 2.98%. So we wind up getting choice 4 there. Number 17 gives us this whole problem explaining our distribution. So our distribution looks to be centered somewhere around 43%. It looks like that's the center. 43% looks like the middle. And we want to know the approximated standard deviation. So if you remember, 95% of your distribution should be within 2 standard deviations of the center. So essentially, I'm trying to figure out what number I can add to this twice to get to almost the top, or subtract to it twice to get to almost the bottom. It shouldn't be all the way to the top, and it shouldn't be all the way to the bottom. It should be almost. So essentially, I want to say, like, if I add 2.2s, will I get almost to the top? Will I get beyond the top? Like, what am I getting? So if I take 0.43 and I add 2.02s, we're going to get 0.47. 0.47 is not near the top, so that's not my answer. If I get 0.43 and I add 2.05s, I'm going to get about 53%. That's really close to the top. So far, that's my winning choice. Let's see the next one. One of them is going to be the obvious answer. The other ones are going to be so obviously wrong, you'll be able to choose the right one. So if I add 43 to 18%, that's going to be 0.61. That's way too big. 43 is enormous. That's not even going to be close. So our best prediction for our standard deviation would be 0.05. And again, it's all based on the fact that 95% of the data in our distribution should lie within 2 standard deviations of center. All right, so for number 18, we need to determine whether or not something is odd or even. Quick review of that concept. Even functions have line symmetry over the y-axis. Odd functions have point symmetry about the origin. Now, basically, if you were to just make a quick example of one, a parabola is going to be even because that would be line symmetry over the y-axis. A basic cubic function is going to have point symmetry because if I rotate it 180 degrees about the center, it's going to be the same graph. So now I need to figure out which of these is going to be even or odd. So let's plug some stuff into Desmos so we can see it. So if you label a function f of x, you can make it so that it has different versions of itself. So we'll say cosine of x, equal sign would help. And remember, we're graphing trig functions, so we want to be in radians. Basically, you should be in radians for this whole test. So if we look at choice 1, it asks us to graph 2 f of x. Well, that red graph is 2f of x. Notice that function is going to have line symmetry over the y-axis. If I was to imagine folding my paper in half along the y-axis, all of those points would land on top of each other. So that's even. If I graph the other option there, which would be f of 2x, we get this blue graph. Well, that graph also is even, line symmetry over the y-axis. So choice 1 is actually true. It's my answer. If we were to plug in some of the other ones, like if I was to plug in f of x plus 2, let's see, f of x plus 2, that's in option 2, that is even, not odd. If I was to flip the graph upside down, the green graph would not land back on top of the green graph. It'd be floating somewhere down here. It wouldn't be where it is now. So the only option here that has both of them as true statements is choice 1. We could go through all the other choices and graph them, but you'll see only one of them is true, not the other one. Number 19 requires us to do a whole bunch of algebra. So the first thing we have to do when we see multiple fractions in an equal or in an equation is we want to create a common denominator. So our common denominator is going to be x minus 5, x plus 2. How do I know that? I can multiply the first fraction by something and the second fraction by something to get that denominator. So we can do that. So my first fraction is going to be x plus 3 over x minus 5, but I want to make the denominator the same as this other one. So I'm going to multiply by x plus 2, and whatever I do in the bottom, I then have to do in the top. Plus 6 over x plus 2. Again, I want to make it look like the other one, so I'm going to multiply x minus 5. The last fraction already has the common denominator, so there's really nothing to do there other than to rewrite it. Once you have that, you can then say everything in the numerator becomes your equation. Since all the denominators are the same, they no longer matter. So if we do some quick multiplying here, x plus 3 times x plus 2. So we have x squared, 3x, 2x, and 6. So we wind up getting x squared plus 5x, 2 and 3 add up to 5, plus 6, plus I can distribute 6x minus 30 is equal to 6 plus 10x. Now to solve this, I see that it has a x squared in it. It's quadratic, so I want to make it equal to 0. So I want to clean the common terms up and move the 6 and the 10x all to one side. So we have x squared plus 11x minus 24 is equal to 6 plus 10x. And if we move the 6x and the 10x to the other side, 10x, so we subtract 6 and subtract 10x, we get x squared plus x minus 30 equals 0. And then we have to factor again. One of the factoring methods you will 100% have to use on this is your trinomial factoring method. So we're trying to figure out what multiplies to make 30, but adds to make 1. That is going to be positive 6 and negative 5. These are not your solutions. The solutions come from setting this equal to 0 and solving, so negative 6 and positive 5 are your two possible solutions. But because these are fractions, we have to check, and we have to see, will either of these make any fraction undefined? So in this original problem, before I did any of this work, I could have determined that x cannot be 5 and x cannot be negative 2. So right away, it can't be these choices. They have 5 in it. 5 can't be an answer. When I did all the math, I saw that 5 was an answer. We call this an extraneous solution. So the only true solution to this is negative 6. Can you do this on Desmos? The answer is yes. You can make two equations, set them equal to each other, see where they intersect. They should only intersect at negative 6. It's just going to be a funny looking graph, and it's going to be hard to read. I'd rather you do the algebra. Number 20 asks us which expression is equivalent to x to the third over y. So here we have to just deal with our exponent properties. So let's start with 1. So if I have something to the negative first power, I can just take the reciprocal of that and make it positive ones. So this would be x to the third over y to the first power. Anything to the first power is itself, so we get the same thing back, so that one checks. The next one, if we use our exponent properties again, so this is a exponent over root again, so this would rewrite to x to the 9 over 3 times 1 over y, because a negative becomes a reciprocal. The reciprocal of y is 1 over y. And if we simplify 9 divided by 3, I get 3. So we have x to the third times 1 over y. And that's all equal to just x to the third over y by multiplying. So that one also checks. The last one has a lot more work, so I'm going to do it over here. So the numerator is x to the 6 times y to the 8 over 4. The denominator is just x to the third, y to the third. Well, if I simplify y to the 8 over 4, I have x to the 6 times y squared, all over x to the third times y to the third. Well, when we divide variables, we subtract their exponents, so that's going to give me x to the third times y to the negative 1. 2 minus 3 is negative 1. And we have just established 2 times in a row that negative exponents become reciprocals, so we can make that just over y. This one also checks, so they actually all work. Number 21 wants us to find an inverse. As soon as we see the word inverse, we are thinking switching x's and y's. So the y here is f negative 1 of x. So they're actually giving you the inverse, and I want us to know the original function. It's the same thing. Inverses have an original. If you take the inverse of an inverse, you get back the original function. So all we have to do is invert this again. So instead of it being y equals, I'm going to make it x equals 2/3 y plus 1/6. If we subtract 1/6, subtract 1/6, we get x minus 1 over 6 is equal to 2 over 3y. To get rid of 2 over 3, we multiply by the reciprocal to the entire other side, so 3 over 2. We then can do some quick distributing and get 3 over 2x minus 1 over, that would be 3 over 12, so that would be 1 over 4 is equal to y. Now in this case, y represents f of x, so we get our answer here of choice 3. Number 22, which of the following equations are identities? Identities means that they are true statements. So we're trying to figure out which one is actually going to be true. So I can use essentially factoring properties to do this, right? This I know is not factorable with real numbers, so that cannot be true because it's a plus. There's no such thing as sum of two squares. X cubed plus y cubed can be factored to x plus y, x squared minus xy plus y squared. That's not what we have here, so that one is not true. And again, there's no such thing as difference or sum of two squares, so that one is also not true. So none of these are identities. Now, if you're looking at that and saying, I can't do that, that's too many x's and y's and there's a lot going on there, pick a number for x and pick a number for y, plug it in and see which ones are true and which ones are not. None of them will come up to be true. If you're randomly picking x and y values, just make sure you don't pick 0 and 1. Weird things happen. Number 23 tells us that the focus of a parabola is 0, 6, and its directrix is y equals 4. Anytime we see the words focus, directrix, we are drawing a sketch. So I'm going to put the point 0, 6. I'm going to put the line y equals 4, which would be below that because 4 is smaller than 6. And then I know my parabola is going to have a vertex in between that point and that line, and it's going to open up. The vertex here is going to have a coordinate of 0, 2. That would be the point in between these two, this point and this line, because the difference between 4 and 6 is 2. No, this will be a 5. 0, 5. I was thinking way too fast. Okay, so the difference between 4 and 6 is 2. Divide that by 2. So I would go up 1 and then up 1 again. So 0, 5 would be right in the middle here. That's my vertex. The p-value is 1. So in our class, we learned that the form of a parabola is going to be this equation. Well, in this case, I know that the h is 0 because that's the x value of the vertex. The k is 5 because that's the y value of the vertex. And the p is 1. So now all I have to do is plug in. So I could say y equals 1 over 4 times 1, which is 4. X minus 0 squared plus 5. Notice that's not a choice. So what we have to do is do some algebra here to get an answer. So we can say this is y equals 1 over 4. Anything subtracted 0 is just itself, so that's really just x squared plus 5. Still not the choice, right? But you could probably cross off 1 and 3. I don't have y squared. I have x squared in my equation. And both of my remaining choices are equal to x squared. So I got to get x squared by itself. So I'm going to subtract 5. So I have y minus 5 is equal to 1 over 4x squared. To get x squared by itself, I'd multiply both sides by 4. So I'd have 4 times y minus 5 is equal to x squared, and that would be choice 2. All right, so the last one tells us that we have a savings account. This account is going to have deposits made on a child's birthday every year, and the account that the deposits are being made in has 4% annual interest. Annual interest is important here. So that's going to tell us that my R, or my increase, is by 1.04. Remember, it's 1 plus the rate. Right? So whatever this annual interest rate is, it's 1 plus that. So what our multiplier is every single year is 1.04. And we're doing this for 21 years. So we have to use our sum formula, right? Our series formula. How do I know to use series formula here? This is a geometric sequence. I know that because it's a multiplier, right? Multiplication becomes geometric. So our equation is S sub n is equal to a sub 1 minus a sub 1 times r to the n divided by 1 minus r. So let's plug it in. Again, this is on the reference table. You don't need to memorize this. So we could say after 21 years of an initial deposit of 500 times 1.04 to the 21st year, all over 1 minus 1.04. So right away, it doesn't even look like 1 or 3, so I can cross those off. Now we're looking at it and saying, all right, so which one could be equivalent? Now, they did some funky algebra here to make this a challenging question. All they did was they factored out the 500 that was common up top. So they said, we notice that 500 is a common term, which will leave us as 1 minus 1.04 to the 21st power, all divided by 1.104, choice 2. If you didn't see that, what I would hope that you'd be able to see is process of elimination. This is not the right R value, so that can't be the choice either. I'm hoping this helped you get through some of these multiple choice questions. Look on my YouTube channel for the part 2, 3, and 4s explained and done out as well. See you soon.